So now that we know how to recognize dependent and independent events, let's look specifically at how we calculate the probability of independent events here. So if A and B are independent events, then we are interested in calculating the probability that both A and B will occur. And we also write this, of course, as the probability of A intersection B. So the probability of these two events, A and B, is just the probability of A times the probability of B. And this shouldn't be too surprising. This is basically the fundamental counting principle that we've been working with since unit number 1. Okay? If we wanted the number of things, we just multiply them together. It works the same way with probabilities. So, for instance here, we've got two questions. First one, a coin is flipped twice. It turns up heads the first time. What is the probability that it will turn up heads the second time? First, we need to ask ourselves, are these two coin flips dependent or independent? Okay? Is the probability or the outcome of the first coin flip going to affect the outcome of the second coin flip? So what do we think? Independent or dependent? Caroline, what do you think? They are independent events. Okay. Why are they independent? Well, if I flip the coin, okay, chances of head of tails is the same every time I flip it. It's always going to be 50-50. So the probability of getting the second one to be heads, okay, if we're only interested in that one single coin flip, the second one turning up heads, it's the same for any other coin flip. Probability of getting heads is going to be 1/2. Okay. Now, let's look at the second part here. If a coin is flipped twice, what is the probability that it will turn up tails twice in a row? Okay. So we're interested in these two coin flips. Now, once again, these two coin flips are independent events. What we get on the first flip doesn't change what we're going to get on the second flip. So let's calculate the probability of the compound event where we consider both of them. We will let A be the event where the first is heads, or first is tails. We'll let B be the event where the second is tails. We want the probability of both of them turning up tails, so both A and B. So the probability of A and B is going to be the probability of A times the probability of B, because these are independent events. So we know that the probability of getting tails the first time around is 1/2. The probability of getting tails in the second one is also 1/2. So the probability of both of them being tails is going to be 1/2 times 1/2, or 1/4. And we could easily verify this by writing out the event space for this. What are our options? Well, we've got 4 possible options: heads, heads, tails, tails, head, tails, tails, head. So only one out of those 4 possibilities is going to give us 2 tails in a row. Let's try a slightly more wordy example here. There's a 70% chance that a teacher will encounter at least one red light on his ride to work. There's a 20% chance he will be cut off by a driver. What is the probability that he will not have to wait at a red light and nobody will cut him off? So the chances of this guy having an excellent ride into work means that, he's not going to wait at a red light and nobody's going to cut him off. First thing we have to ask ourselves, are these two things dependent or independent events? Is the chances that he's going to be cut off by a driver somehow influenced by whether or not he's going to run into a red light? What do we think? Independent or dependent? These are independent events. So we could now, let's see, let's define what our two events are. We'll let A be the event where there are no red lights. And we will let B be the event that nobody cuts them off. I'll just say not cut off. Okay. We want the probability of both of these two events. The probability of A and probability of A and B. So I'll just write over here that this is what we're trying to find. We know the formula that we're going to use here. It is going to be the probability of A times the probability of B because these are independent events. Now, from our reading of the question, what is the probability of A? Are we given this in the question? And this is where it gets a little bit tricky here, Cal. Yeah. We are given the probability of the complement, okay? We want A to be the probability that there are no red lights. We are given the probability that they will encounter a red light. So we've talked about complements before. So the probability of A is going to be 1 minus the probability of its complement, okay, A primed, which is what we are given in the question. So the complement of no red lights is at least one red light. So we want for the probability of A 1 minus that 70% chance for 0.30. For the probability of B, let's take a look. B is the event where he is not cut off by a driver. What do they tell us here? They tell us that there's a 20% chance that he will be cut off by a driver. So they've given us, again, the probability of the complement. And I could label that as the complement as well. So the probability of event B is going to be 1 minus the probability of the complement. So 1 minus 0.20 or 0.80. So now that we have the probability of A and the probability of B, we can calculate the probability of A and B. It's just going to be the probability of A times the probability of B. So we're going to take our 0.30, multiply it by our 0.80, and get 0.24, or 24%. So there's a 24% chance that this teacher is going to have a great ride into work and not be cut off and not have to stop at a red light.